Welcome to the DIY Honda Garage Channel. The DTC P1684 indicates a performance problem specifically related to the throttle valve return spring in Honda Civics from the years 2006 to 2011. This error code is significant as it can affect the engine's ability to idle correctly, directly impacting overall vehicle performance and safety. The throttle valve, which regulates the amount of air entering the engine, is highlighted as the component of interest here. Its return spring is crucial for ensuring the valve returns to its closed position when the accelerator pedal is released. If this spring malfunctions, it can lead to unintended acceleration or poor engine response. Therefore, understanding this DTC is essential for diagnosing throttle-related issues that may arise in the Honda Civic. DTC P1684 points to issues with the throttle valve return spring's performance, highlighting its vital role in the throttle body. The throttle valve itself is responsible for controlling airflow into the engine and is located within the throttle body, which sits typically on the intake manifold of the vehicle. The throttle valve return spring's primary function is to ensure that the throttle valve returns to a fully closed position when not actively operated. This precise functionality prevents unintended acceleration and supports vehicle stability. Additionally, the connection between this spring and the engine's electronic control module, ECM, or powertrain control module, PCM, works in tandem to manage engine speed and operational efficiency. Therefore, examining both the throttle body and its spring mechanism is critical in addressing issues flagged by DTC P1684. Several factors can lead to the activation of DTC P1684. The faulty throttle body is one common cause, which could result from mechanical failure or carbon buildup affecting the throttle valve's motion. Poor electrical connections are another significant issue, as loose or corroded terminals at either the throttle body or the ECM/PCM can disrupt signals necessary for proper throttle operation. Also, a worn throttle return spring may not provide adequate force to return the throttle valve to its closed position, causing the performance problem flagged by this DTC. Each of these causes can affect the vehicle's throttle response, and as such, must be thoroughly investigated during diagnostics to ensure reliable repairs. DTC P1684 can manifest several noticeable symptoms that indicate underlying issues with the throttle valve return spring. One primary symptom is erratic engine idling. The engine may rev unexpectedly or fail to maintain a steady speed when the vehicle is stationary. This instability can lead to poor acceleration response, where the vehicle does not accelerate smoothly or as expected when the throttle pedal is pressed. Additionally, the driver may experience potential stalling issues, where the engine unexpectedly shuts off, particularly when the vehicle is idling. Recognizing these symptoms is critical for an effective diagnosis and ensures that proper care is taken to address the DTC P1684, ultimately making the vehicle safer and more reliable. The first step in troubleshooting DTC P1684 involves turning the ignition switch to the on/to position. At this stage, it is crucial to record all freeze data, which provides insights into conditions that led to the DTC being triggered. This data can include engine load, temperature, and speed, among other parameters. Reviewing general troubleshooting information is also a foundational step that prepares the technician for the following diagnostics. This process gathers vital historical data, essential for effective diagnostics and remediation of the underlying issue suggested by the DTC. Taking these initial steps seriously ensures that no critical information is missed, setting the stage for effective troubleshooting ahead. In the second troubleshooting step, The next action is to clear the DTC using the Honda Diagnostic System, HDS. This system is a specific diagnostic tool designed to interface with Honda vehicles, allowing for efficient communication with their onboard computers. By clearing the DTC, the technician resets the vehicle's diagnostic computer so that any immediate issues can be identified accurately during the subsequent steps. This action also eliminates any stored fault codes that are not currently active, allowing for a fresh start in monitoring the vehicle's performance. It is a vital part of the troubleshooting process, ensuring previously saved data does not interfere when diagnosing persistent issues related to DTC P1684. After clearing the DTC, the technician proceeds to start the engine and hold the engine speed at 3,000 RPM without any load. The vehicle must be placed in park or neutral for automatic transmissions or in neutral for manual transmissions. This step is crucial as it forces the vehicle's engine to operate at a heightened RPM, aiding the diagnostic process further. The technician must monitor this stage until the radiator fan activates, which usually signifies that the engine has reached a predefined temperature. This action also serves as a stress test for the throttle body. Monitoring the throttle performance under these conditions helps identify whether the system is functioning correctly. If any abnormalities are experienced during this step, they must be documented and analyzed in context with DTC P1684. In Step 4, the technician is instructed to turn the ignition switch to the lock 0 position, after which a waiting period of 10 seconds is required before proceeding. This waiting period allows for the engine control module, ECM, to reset and correctly establish its operational parameters. It is essential for ensuring that the vehicle systems transition properly from active diagnostic testing back to regular operating mode, ultimately preserving data integrity and functionality. Ensuring a proper pause is crucial to avoid conflict or erroneous readings in future diagnostic steps. This systematic approach helps ensure that subsequent actions yield accurate results and appropriate responses from the vehicle's electrical and mechanical systems. Step 5 requires the technician to turn the ignition switch to the on second position once again. This position powers the vehicle's electrical systems, including its diagnostic systems, albeit without starting the engine. This step prepares for further diagnostics and allows a new round of checks to be performed on the vehicle's systems, specifically checking for any new or clear DTCs that may have appeared since the last clearing of the fault codes. It also ensures that any lingering codes or issues are promptly addressed. This methodical approach is crucial, as it emphasizes the need for thoroughness in diagnostics, further ensuring that all aspects of the throttle valve return spring's functionality are monitored effectively. Upon turning the ignition back to on, second, the technician should check for any pending or confirmed DTCs utilizing the Honda Diagnostic System, HDS. A pending DTC indicates that while the issue may not be severe enough to illuminate the check engine light, it nonetheless requires attention. In contrast, a confirmed DTC indicates that the problem has been recognized as existing and needs immediate action. The discovery of DTC P1684 at this step confirms that a throttle valve return spring performance issue persists, guiding the technician toward the next immediate actions. Identifying the status of these errors forms an essential part of the overall troubleshooting process, allowing for accurate diagnostics and strategizing appropriate steps for remedy. Step 7 instructs the technician to turn the ignition switch to the lock 0 position. This action is essential for ensuring safety while proceeding with further inspections. the technician must take precautionary measures before diagnosing and inspecting the throttle body directly, as this can be dangerous due to the possibility of electronically controlled systems being active. Switching to lock disengages these systems, providing a safer environment for troubleshooting. Proper engagement with such diagnostic steps is crucial. It prevents injuries that might arise from inadvertently activating throttle-related components during the inspection process, thus maintaining safety throughout the repair process. In Step 8, the intake air duct must be disconnected from the throttle body to allow for direct access to the throttle mechanism. Care should be taken to avoid damaging any associated components during this disconnection. With the intake air duct removed, the technician gains clear visibility of the throttle cavity, allowing for more accurate diagnostics and potential repairs. This step is vital for preparing the throttle body for the subsequent inspection, helping in verifying whether the throttle valve is functioning correctly. Ensuring a clean and accessible throttle body area allows the technician to examine the physical mechanisms adequately, which is critical when dealing with concerns highlighted by DTC P1684. In Step 9, the technician is instructed to push the throttle valve open manually. This hands-on approach allows for a direct inspection of the valve's operation and its responsiveness to manual inputs. The technician should observe how the throttle valve reacts to being opened. It should move smoothly and without hesitation. Additionally, it's important to check for any blockages or obstructions that may hinder the valve's operation. This step provides significant insights into the overall condition of the throttle body and its components. If the valve does not function normally during this check, it raises further concerns about mechanical failure inside the throttle body assembly, which must be addressed in the following steps of troubleshooting. After manually pushing the throttle valve open, the next action in Step 10 is to release the throttle valve. Observing whether the throttle valve returns to its resting position is crucial in determining the functionality of the throttle valve return spring. If the valve returns smoothly without the need for further assistance, it indicates that the spring is operating correctly and has not failed. However, if the valve does not return to its closed position, this suggests a failure in the throttle return spring mechanism or obstruction preventing its movement. Proper evaluation during this step is vital for determining whether to proceed with cleaning the throttle body or address potential replacement needs, profoundly impacting the resolution of DTC P1684. In Step 11, if the throttle valve does not return smoothly to its closed position, the technician is required to replace the throttle body. The reason behind this step is that a malfunctioning throttle body significantly compromises the vehicle's throttle system, leading to the symptoms indicated earlier in the troubleshooting guide. Replacing the throttle body allows for a fresh start with a new mechanism, ensuring reliable performance. Conversely, if the throttle valve returns correctly, the next action should be to clean the throttle body thoroughly. Ensuring all dirt, grime, and carbon buildup is removed can be vital for the proper operation of the throttle valve, and is often a necessary maintenance step to prevent recurring issues represented by DTC P1684. In Step 12, the technician must again turn the ignition switch to the on second position. This action prepares the vehicle systems for a reset of the engine control module, ECM, or powertrain control module, PCM. By doing so, the technician ensures that any modifications, whether through repair or cleaning processes, are acknowledged by the vehicle's onboard computer systems. Activating the ignition this way enables the systems to perform their necessary checks and prepares them to receive further instructions. This step is particularly crucial, as resetting the ECM or PCM allows it to recalibrate and adjust based on any new or repaired components, ultimately contributing to the optimal performance of the vehicle. The 13th step in troubleshooting DTC P1684 involves resetting the Engine Control Module, ECM, or Powertrain Control Module, PCM, using the Honda Diagnostic System, HDS. This reset is essential for erasing any stored DTCs and confirming that all diagnostic checks are up to date. By employing HDS, which allows for precise and reliable communication with the vehicle's systems, the technician can ensure that all error codes related to previous issues are cleared. This action signifies the completion of the repair or cleaning protocols and prepares the vehicle for final evaluation. Following a reset, the ECM or PCM will recalibrate its parameters, thereby allowing recent sensor readings to inform the system about the vehicle's current operational state. In the final troubleshooting step, the technician must execute the ECM/PCM idle learn procedure. This step is critical following any repairs involving the throttle body to recalibrate the idle parameters of the engine control module. Performing this procedure ensures that the ECM or PCM effectively learns the ideal idle speed and behavior of the engine under various conditions. It helps the vehicle achieve optimal performance by aligning its operational settings with the current engine setup. Failing to execute this step could result in poor idling performance, stalling, or erratic engine behavior. As a result, confirming the engine operates smoothly post-repair solidifies the successful completion of resolving the issue related to DTC P1684. After all troubleshooting steps related to DTC P1684 have been executed, thorough verification of the repairs is necessary. The technician should assess the throttle body performance to ensure that the throttle valve returns properly and operates without obstructions. Any lingering symptoms present before repair should be monitored for any reoccurrence, offering assurance that repair efforts were effective. Confirming that no new or stored DTCs emerge will further support the success of the repair process. This verification step acts as a crucial final check, solidifying that the vehicle's performance aligns with manufacturer specifications and confirming that any issues flagged by DTC P1684 have been resolved satisfactorily. As part of preventive maintenance to avoid similar issues in the future with DTC P1684, regular throttle body cleaning should be performed. Buildup of carbon and residue can significantly affect throttle performance over time. Thus, consistent cleaning ensures that the throttle valve operates smoothly. Additionally, incorporating routine inspections of electrical connections linked to the throttle body and ECM/PCM can uncover potential issues before they escalate into more significant problems. Ensuring that all connections remain clean and secure allows for dependable communication within the systems, effectively mitigating the risks of recurring DTCs associated with throttle performance. Advocating for these preventive measures contributes to long-term vehicle reliability and the smooth operation of the throttle system. In summary, DTC P1684 is indicative of a throttle valve return spring performance problem in the Honda Civic from 2006 to 2011. The troubleshooting process involves multiple systematic steps to ensure thorough diagnostics and repairs, emphasizing the importance of each action for resolving the underlying issue effectively. Regular maintenance and inspections are crucial for the long-term reliability of the throttle system, enabling smoother engine operation and preventing the recurrence of similar faults in the future. Understanding the roles of each component involved, as well as the interplay between them and the ECM or PCM, solidifies a technician's capacity to address complexities related to DTC P1684. Ultimately, Thorough diagnostics, accurate repairs, and proactive maintenance ensure that vehicle performance and safety are optimized for the driver. Please like and subscribe to the channel. See you next time.